So on this question, we want to evaluate this limit. We have the limit as x approaches 5, square root x plus 11 minus 4 over x minus 5. Our first strategy for finding limits is direct substitution. So I'm going to substitute this 5 in for the x's, and that will give me square root of 5 plus 11 minus 4 over 5 minus 5. Inside the radical, we have 5 plus 11, that's 16. And in the denominator, 5 minus 5 is 0. Square root of 16 is 4. And in the numerator, I have 4 minus 4, which is 0. So we did get division by 0, and division by 0 is undefined. So direct substitution didn't work to give us the answer here, but it has given us some information. When we get this 0 over 0, that's called an indeterminate form, meaning that the answer could be multiple different things based on whatever expression was given. So when we get that 0 over 0, that means that we have a common factor that we can cancel out. So if we use some algebra techniques, we'll be able to rewrite this expression, cancel that common factor out, and then hopefully use direct substitution to get the answer. So I'm going to rewrite my limit here. The limit as x approaches 5, square root of x plus 11 minus 4 over x minus 5. So the strategy, the algebra strategy that I'm going to use to simplify this expression is going to be to rationalize. So this radical is my clue to use that method of rationalizing. So I'm going to multiply by the conjugate of the numerator. And the conjugate of the numerator just has the opposite sign in between those two terms. And this is a strategy for rationalizing, and rationalizing means that you're going to get rid of the radical. So in this example, once we've done this simplification, we'll no longer have a radical in the numerator. So I'm multiplying by the conjugate of the numerator. In the numerator, when I do my multiplication, I'm going to do square root of x plus 11 times square root of x plus 11. That simplifies to be x plus 11. Let me write that limit symbol here. And then when I multiply the outside and the inside, you'll notice that because I multiplied by the conjugate, I have the same terms but with opposite signs, one with a plus and one with a minus. And so those terms will cancel each other out. And then I'll multiply the last two terms together. Negative 4 and positive 16 will give me a minus 16. I think I misspoke there. Negative 4 times a positive 4 gives me a minus 16. In the denominator, I'm going to leave this in factored form. So I'm not going to multiply everything out. I'm leaving it in factored form because I'm hoping that one of these factors will cancel out once we've simplified the numerator completely. So I have a factor of x minus 5 from here, from this fraction, and a factor of square root of x plus 11 plus 4 from the other fraction. I'll continue simplifying the numerator. And in the numerator, I have like terms, a positive 11 and a negative 16. That leaves me with x minus 5 when I combine. And I'm copying down the denominator. And you can see that we do have a common factor, a factor of x minus 5 in the numerator and denominator. Those will cancel out. And I have the limit as x approaches 5 of 1 over square root of x plus 11 plus 4. And now that I've canceled that common factor out, I'm going to try direct substitution again. I have 1 over the square root of 5 plus 11 plus 4. That's 1 over the square root of 16 plus 4. Square root of 16 is 4. So I have 1 over 4 plus 4, that's 1 over 8. And since this question asks for a decimal answer, I will type 1 over 8 in my calculator to get 0.125 as the decimal answer. So we found the limit to be 0.125. On this question, we want to evaluate the limit. We have the limit as x approaches 5, 1 over x minus 1 over 5 over x minus 5. When we first try to find a limit, we're going to start with the method of direct substitution. So if I use direct substitution on this limit, that would give me, I take this 5 and substitute it into the x's, so that'll give me 1 over 5 minus 1 over 5 over 5 minus 5. 1/5 minus 1/5 is 0. 5 minus 5 is 0. We have division by 0, which is undefined. But even though we didn't get an answer here, this 0 over 0 is an indeterminate form, and because we got 0 over 0, that indicates that there may be some algebraic technique that we can use to simplify this expression and cancel out the factor that's causing the denominator to be 0. So I'm going to rewrite this limit. So the limit is x approaches 5, 1 over x minus 1 over 5 over x minus 5. And because this is an expression with a complex fraction is when you have a fraction inside of a fraction. So because this is a complex fraction, I'm going to use the strategy of clearing fractions. So I'm going to multiply the numerator and denominator by the least common multiple of these denominators here. So I'm going to multiply by 5x over 5x. This is going to clear the fractions. So I'm going to use the distributive property and distribute the 5x to both terms. That'll give me the limit as x approaches 5, 5x over x minus 5x over 5. And in the denominator, I'll leave this in factored form because I'm hoping that there'll be a common factor to cancel out. We have 5x times x minus 5. In the numerator, the x's cancel and the 5's cancel. And I have the limit as x approaches 5 of 5 minus x over 5x times x minus 5. And I'm looking to see if I have any common factors to cancel out. I don't have a common factor, however, these two factors are very similar to each other. We have 5 minus x and x minus 5. So they're the same expressions but with the opposite sign. So what I can do is I can factor out a negative 1 from the numerator. If I factor a negative 1 out, that's going to change that 5 to a negative 5 and the x to a positive x. And now these two factors are the same, and so they can be canceled. So I have the limit as x approaches 5 of negative 1 over x, negative 1 over 5x. And I should be able to use direct substitution. That's negative 1 over 5 times 5. That's negative 1 over 25. And this question specifies decimal form. So I'll type in my calculator 1 over 25, and that gives me 0.04. So it's negative 0.04 for this limit. On this question, we want to evaluate the limit. We have the limit as x approaches 3 pi over 2 of cosine x over cotangent x. We're going to start with direct substitution. So we're going to substitute this 3 pi over 2 into both x's, and that will give me cosine of 3 pi over 2 over cotangent of 3 pi over 2. And to evaluate this, I need to remember the unit circle. And on the unit circle, an angle of 3 pi over 2 is right here, 3 pi over 2. And that point on the unit circle is 0, negative 1. I also need to know the definition of cosine of theta of an angle will be the x, and cotangent of the angle will be x over y. So I'll use those coordinates to get those. So for cosine of 3 pi over 2, I'm going to use the x coordinate. The x coordinate is 0. And for cotangent, we'll do the x coordinate of 0 over the y coordinate. So 0 over negative 1 is 0, and we get an indeterminate form of 0 over 0. So division by 0 is undefined, so we didn't get an answer, but the fact that we got 0 over 0 indicates that we can do some simplification. So I'm going to try to simplify this trig expression to see if any factors cancel out. So one of the strategies for simplifying trig expressions is to try to write everything in terms of sines and cosines. So we already have the cosine in the numerator. I'm going to try to rewrite cotangent in terms of sines and cosines. So we have a trig identity, which is called the quotient identity for cotangent, and the quotient identity says that cotangent x is the same thing as cosine x over sine x. So using that trig identity, I'll start with my limit again. The limit as x approaches 3 pi over 2 cosine x over cotangent x. That is the limit as x approaches 3 pi over 2 of cosine x, and I'll use that quotient identity in the denominator. So that becomes cosine x over sine x. So now we've created this complex fraction. We've got a fraction inside of a larger fraction. So I'm going to change this fraction bar to division and write this as the limit as x approaches 3 pi over 2 cosine x divided by cosine x over sine x. And when we divide fractions, we need to change it to multiplying by the reciprocal. So that would become the limit as x approaches 3 pi over 2 cosine x times sine x over cosine x. And we can see we do have a common factor of cosine that cancels. And now that gives us the limit as x approaches 3 pi over 2 of sine x. And now that that factor has canceled out, we can use direct substitution. So I'll substitute this 3 pi over 2 into x. And I'll have sine of 3 pi over 2 sine of an angle is the y-coordinate. So we get the y-coordinate at our angle of 3 pi over 2 being -1. So we've got this limit equaling -1. Thank you for checking out my videos. Have a great day.